Hello there, this is the second video in a four-part series, and in this video I'm going to show, again, using this data logger, but logging at regular intervals. So in the previous video I went through this a little more about what's on this DIY Arduino shield. So if you want to know sort of what the different components are on this, please have a look at the Instructables that goes along with this video, or have a look at that previous demo. So in this setup I'm going to have one of these. This is a thermistor. So this is a resistor that changes its resistance in response to changes in temperature. So because it's a resistor, I'm going to use it with this. This is a 10 kilo ohm resistor. And so if you know about resistors, when you connect them in series and you run a voltage through them, okay? So here they're connected in the middle. Then as this resistance changes, then the voltage between them will change. And so the Arduino is going to use an analog pin to measure that voltage, and then it can calculate what the temperature is, okay? The other thing I have here is a light. So this is an indicator light. I'm going to put it on pin 13. There is a light on pin 13 on the Arduino, but I can't see it because the shield is in the way. Can't see it on this video, so I'm just going to add it here. And this is just my indicator, so I know when the card is saving. Okay, and I'll get into that. But let's set this up. So we're going to take advantage of the 5 volts on the Arduino. So I'm going to put one end of my voltage divider, okay, there. I'm going to put ground at the other end. There, and then the junction between them, I'm going to use an analog pin, so I'm going to use analog A0. Okay, the first analog pin. Okay, and then like I said, I'm going to have my indicator light. Let's use red since we have a red LED. I'm going to connect it to pin 13. So there's 13 there. And that goes to our small little LED. Okay, so that's connected to the LED. It's connected to a 220 ohm resistor just to limit the current that goes through the LED so it doesn't burn out. I could use this ground line, but I'm going to keep them separate. Okay, it's a good idea when you're using, when you're measuring. It doesn't really matter for this project, I guess, but when you're doing analog measurements, if you have, too many ground lines sort of daisy chained together, that can affect your measurement. Okay, it can affect the voltage through your voltage divider. Okay, so there's our setup. Now let me just show you the code, and then I'll show you this at work. So let's go to the computer. So if you saw the previous demo, this is very similar. So I won't go through all of it in as much detail, but just to kind of orient you. So here's the wire library and our library for our real-time clock that we're going to use to keep track of the date and time. Okay, and so we're going to start that here, create an object. Here's our code for our libraries for our microSD card reader. So we know how to communicate with the card reader and our chip select pin. This is new, so this is our recording LED pin. And like I said, it's on pin 13. So the purpose of this is because we're going to be recording continuously at regular intervals. So if you were to unplug your Arduino when it's in the middle of recording, then you could lose all your data. So if you've been recording all day, you unplug it just as it's doing its last measurement and saving it, then you're going to lose the whole day's worth of data. Okay, so you don't want that. So in this example, I'm recording every 5 seconds for the purposes of this video. But at least I can see when it's recording, and then I know I have 5 seconds where I can safely unplug my data logger to help prevent losing that data. Okay, so very important to have some sort of mechanism where you won't record over your data, or sorry, you won't corrupt your data. Okay. Our temperature pin is going to be on analog A0, so we're just declaring our pin as 0. And then, like I said, we're measuring at regular intervals. So I thought the easiest thing to do was use the millis function, which is part of Arduino, part of the Arduino IDE, and it just counts the number of milliseconds since the Arduino was last turned on or reset. And it can become a very big number. It can actually be big enough to account for like 49, 50 days, okay, just under 50 days. So it can be quite big. But once it does reach the end of that, it goes back to zero. Okay, so it resets back to zero. So I kind of tried to account for that in the programming here as well. Okay, so I'll show you that. So because we're using that, we need to record when we last measured and saved data. So this variable we call previous millis, so prev millis, okay? And if you know millis, the kind of number is an unsigned long, okay? There's no negative values, okay? And it's a long, so it's an unsigned long. So we want to use our previous millis as a similar kind of function. Okay, so this is also an unsigned long. And then here we can set up our interval. Okay, so this is also going to be an unsigned long, and it's going to be constant, so const. Okay, so that just affects how Arduino will save this variable in its memory. But maybe save some space. But we're setting up as 5,000 milliseconds. Okay, so 5 seconds. But if you're downloading this sketch, again, it's in the Instructables in demo 2. But if you download this, you want to play around with it. If you change this value, you can change the interval. Okay, so if you wanted 1 minute, you would put 60,000. If you wanted an hour, that's what, 360,000 milliseconds. Okay. Just to note, I haven't tested how accurate it is over the long term. So if you had like 24 hours worth of milliseconds in here, I'm not sure if you would get down to the exact millisecond, but for most purposes, this works well. Okay. So that's setting up our interval, and then we go to the setup. So again, same as the previous demo, we're going to use our serial monitor so you can see in this video what's happening, and if you're using this for troubleshooting. But ultimately, if you have your project set up and it's working well, you can get rid of all the serial statements. Here we're starting our I2C communication with our real-time clock. And again, the 2 lines here that I use for resetting the clock, they are commented out, so they're not being used here. But again, look at the previous, look at the Instructables if you want to see how to set your clock using these. We're going to set our LED pin as an output, and then here we're going to initialize our card. Okay, so because we're doing that, we're going to turn our LED on. We're going to start things up. So here's the chip select pin as an output, and then here this statement to begin communication with the microSD card reader. If it doesn't work, then we're going to indicate that and turn the light off and then stop the program. But otherwise, if it works, we're going to make a note of that. And then we're going to open our file. Okay, so this line here will create this file in the microSD card, or if it's already there, it'll just open it. Okay, again, it's a comma separated values, so all our different sort of values, if you will be separated by comma, so we know where one ends and the next one begins. These kinds of files, CSV, can be opened in Excel, it can be opened in Notepad. Okay, so that's how you would look at it after the fact. So if that worked, then we're going to start by just printing a blank line. So you'll see this is just a number of commas with spaces in between. So again, if we stop this and then started it up again, we can see where that occurred very easily, okay, because there's a blank line. After our blank line, we're going to set we're going to write the headers so we know what each column represents. So month, day, hour, minute, seconds, and then we're doing temperature. So we're going to write Celsius in our last column. Now that we've written it into our SD card into the file, then we want to close the file. Okay, very important. Here we're just sending to the serial monitor what we just wrote, and then we're going to turn our LED light off because we're no longer writing to our file. If this up here, if this line didn't work, this would be false or negative, or 0, not negative, but 0. Then we wouldn't run this, we would just run this. Okay, so it didn't open, and then turn our light off. So here we are in the loop, and the only thing we have is this if statement here. Okay, one long statement. And so we're just checking in this statement if it's time to check the temperature and record the data. So what we do is you use that millis function. Like I said, it's been counting in the background since the Arduino was last reset. And we subtract the last time we recorded. So this will start at 0 by default. And if the difference is more than our interval, then we're going to continue on with all of this code. Okay. If it hasn't been 5 seconds yet, then we will not have the difference here between these two will not have reached this. So we'll just skip over this and keep going through the loop over and over again. These two lines here mean or. Okay. And so if this is not true, but this is over here, then we would continue on with this. So what this is again, it looks at the millis, and if it's less than the previous time, the only time this would occur is if, again, it's been more than the 49 days worth of milliseconds and it's gone back to 0. So once it goes back to 0, when we come up to this to check, this will be very high, millions, I think, millions. And then this will be close to 0. Okay, so it won't be exactly 5 seconds since the last measurement, but at least if we didn't have this, this would never be true, right? So it would just stop logging the data. So at least then we account for that rolling over back to 0. And it'll continue measuring every 5 seconds from then. So if either one of these are true, then we're going to go into all of this. Okay, so the first thing that we do is we're going to update our previous millis, so we know next time around, when it's time. This code here actually measures the temperature. This comes from an Elegoo starter kit that I had that got me into Arduino. And so what they do is they take a measurement on that analog pin, and they store it in this variable here. Okay, and then using this variable, in these two lines, they calculate what the temperature should be in Kelvin. So it kind of depends on your thermistor. If it's different, this might be a little bit inaccurate. But this is what Elegoo uses to calculate temperature. Okay, so once we have the temperature in Kelvin, then this line actually will convert that Kelvin into a value for Celsius. Okay, and you'll see here it is a float. So a float is a kind of variable that has decimal places. Okay, and the default is 2 decimal places. So now we have our temperature. So now that we have our data point here, now we're going to refresh the RTC, RTC refresh. So again, we access the time and date from our real-time clock, and then we're going to write to our file. So the first thing we do is turn a light on so that you, the user, knows that you're recording. And same as in the previous demo, we're going to create our data string, okay? Because we're going to save a series of characters, not a series of values. Okay, so the real-time clock has a value which is an integer for the month. So we're going to convert that to a string, and then add a comma, and then add the next string, which is the day, and then a comma, and then hour, comma, minute, comma, second, comma, and then here we're just going to write our temperature as a string and add it to the rest of the data string. Okay, so that's our data string. Like I said, so a string is a series of characters. So, for example, if it was 20.51 degrees Celsius was our measurement, this would store it as 20.51. Okay, and then those characters would be added to our data string. Now that we have our string, again, just a note to the user that we're about to record, and then here we open the file, and if that worked, okay, this will be true, this will be 1, and we go through this, which is we write our data file into our microSD card, and then we close the file. Now that we're done, we turn our light off, and then we just print to the serial monitor the confirmation of what we just recorded. If it didn't open, so this would be a 0 or a false. So then we would skip down to here and then make a note of that in our serial monitor and then turn the light off. Okay. Again, here we have the serial flash, which just clears the serial buffer, right? And then that's the end of our if statement area, and then that's it for our loop, right? So it's just going to go through the loop over and over again, thousands of times a second, and when it comes just past 5 seconds, it'll run through this, take the temperature, create the timestamp, save it, and then it'll wait again for another 5 seconds. Okay, so let me just show you that. So first I have to upload this. So I haven't actually, like I said, I was playing with it. If you saw in the last demo, I was playing with it before. So the file's already on the card, but let me just upload this. Okay, so now that it's uploaded, I actually have to put it on our microSD cards. Let's do that. And let's open the serial monitor. So it's ready. And so without doing anything, it should actually start recording on its own. So 22.79 degrees Celsius, now at 9:44 a.m. on March 26th. And you'll see it just going every 5 seconds on its own. Okay, fluctuating by, I don't know, 0.2 of a degree Celsius. So let's try. And the other thing to see is, I think you can see that flashing light when it records, so right there. So let's try heating it up a little bit with my fingertips. It's 28.61, 31. Oh, don't pull it out. I almost pulled it out. Okay, 33, and then I'll let go. Okay, going down now, 28. Okay, so I'm going to show you now. So I want to make sure that it records, and then I'm going to unplug. Oh, no, I missed it. Let's make sure I don't corrupt my data. So they're recorded and unplugged. So let's put this into the computer and have a look at Excel. Okay, so here we are again. Whoop, here, this is our microSD card. And then the file that we just wrote to was data CSV. Let's open that. You'll notice that the file name is all in caps. So that's different than what we had in our program. Whoops, whoops, whoops. There we go. There's the previous one. It was still open. There we go. I was playing around with it yesterday. This was March 25th. So let's go down to March 26th. So here, this is the data that we just recorded. Okay, so March 26th, 9:44 a.m. Okay, it's I think it's set to the 24-hour clock, so it's 9:44 a.m. And then you'll see every 5 seconds there's another measurement. Okay, and so here are our values. So if you wanted to have a look at this in a graph, let's say, if I highlight those and I come to insert, because I want to insert a graph. So let's just use this one. So there. Okay, and of course you can play with options, but here's the temperature. It's relatively stable. Then I pinched it with my finger and it went up to, oh, I don't know, 33 degrees here, and then it started to come back down. Okay. I didn't tell it what the x-axis is, so it just kind of numbered it. So you could, create a column with the minutes and seconds and create a sort of running tally of seconds, I guess. And so you can see over time what happens. But anyway, so that's our data logging with regular intervals. So there's an example of using analog data, recording at regular intervals, data logging with a timestamp. Okay, so I hope that was useful. In my next video, I want to try using wireless communication. And so I guess that's telemetry, sending data through the air and recording with a timestamp on our microSD card. Okay, so stay tuned for that. Thank you for watching.